Alright guys, welcome to our channel once again. Today you'll learn about reactants, types of reactions, and reaction mechanism. So reaction mechanism usually refers to how reactions occur. And how reactions occur is referred to as the pathway followed to form products. In the pathway or pathways between reactants and products, bonds are broken, bonds are also formed, and the order in which these occur is very important. So a complete mechanism must account for all reactants used, all products formed, and the amount of each. So let's look at the two ways of bond cleavage. So the two ways of bond cleavage we have number one to be homolytic cleavage. And then we have the next to be heterolytic cleavage. So a bond can break or cleave in an electronically symmetrical way. In this case, one electron remains with each product fragment. Now, for instance, let's see this. Let's say I have a reactant here, A, and then it's reacting with another B to form a product here. Now, if this should cleave in a homolytic cleavage process, now this takes part of the electron, and this also perhaps takes part of the electron. So the products formed, we have A, and then we have B. So if I have this, and this is ethane, if I have a homolytic cleavage of this, part of the electron will go for this and part of this will go for this. So I'll have my products formed here, CH3 plus CH3. So now for heterolytic cleavage, the electrons will have to go for one of the reactants. So we say that the bond break or cleave in an electronically unsymmetrical way. So for a product to be formed here, this bond will break in a manner that just one of the products takes up the electron. So this leaves the other as electron deficient. So with this, I'll have the products to be this. So let's still look at the ethane structure we used earlier on. No, now if a heterolytic cleavage should occur, one of these will have to take the whole electron. That's the bonding electron has to go for one, and then the product formed will be such that we have this plus this. So this is carbocation and this is carbanion. So before we proceed, let's consider the electrophils and nucleophiles. So electrophils are basically a group of atoms that accept electrons. For instance, we have this NO2 plus, we have NO plus, we have CO2, we have SO3, we have BF3, we have AlCl3, we have Br2O3. So all these are electrophils. That is, they are electron acceptors. On the other hand, nucleophiles are electron donors. Perhaps they are negatively charged. We have the hydroxyl ion, we have the CN, we have RO, we have RS, we have CO2, kill with the CO2. So all these are nucleophiles. That means they are negatively charged, they donate electrons. However, some nucleophiles can still be neutral, such as the NH3 and then the H2O. So let's understand that there are two ways of bond formation. It can be homogenic bond process, it can as well be heterogenic bond process. Now, with the idea of bond cleavage, we can as well attempt the bond formation. Now, a bond can form in an electronically symmetrical homogenic process. So for instance, let's say I have a reactant here, A, plus another B, which both of them are electronically symmetrical. The charges are the same. So if these two should react, this will lead to a homogenic bond formation, where both A and B donates the electron needed for such bond formation. So this is homogenic. On the other hand, they can also be electronically unsymmetrical. That's heterogenic, where this is positively charged and this is negatively charged. Now, like we know, this will have to donate the electron needed for the bond formation, and as such, this will produce a heterogenic bond. So this is a heterogenic bond formation over here. So let's go ahead and look at the classification of organic reactions. So we can simply classify organic reactions as addition reaction, substitution reaction, elimination reaction, and rearrangement reaction. So I'd like you to just simply know these reactions for what they are, and it's easy or simpler to know them that way. Let's simply start with the addition reaction. Now, in an electrophilic addition reaction, alkanes react with electrophils such as HBr, that's hydrogen bromide, to yield saturated addition products. So for instance, if I have an ethene here, now if it should react with this, it will yield a saturated compound, that is a compound without a double bond. And what's this compound? Ethane. So this is an example of an addition reaction. So what if I have, let's say, CH2, okay, from the example I've given, let's say I have this plus the hydrogen bromide. Now, an addition reaction of this will add to this, and then the double bonds will be broken, and we realize this. So the reaction occurs in two steps. First, the electrophile adds to the alkene double bond to yield a carbocation intermediate, which then reacts to yield the addition products. So let's look at this. I have an alkene here, so I simply have just a hydrogen, a hydrogen, and a hydrogen. Now if this reacts with this, the first reaction we'll have is a carbocation reaction. So notice that this bond has been lost. So this is hydrogen, 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 hydrogen. And then the bromide here now adds to this. So ultimately we will have so that's it. So the next is substitution reaction. So substitution reaction is a reaction where an atom or group of atoms are already present in a molecule. So let me simply illustrate this. Let's say I have this plus this. Now in a substitution reaction, C here will have to replace the B here, and then in the product I'll have AC plus B. So in this case, this is a substitution reaction. So the substitution reaction can be a nucleophilic alkyl substitution reaction or an electrophilic aromatic substitution reaction or a free radical reaction. So let's consider the nucleophilic alkyl substitution reaction. If I have this compound reacting with this compound, now in a substitution reaction, this will have to replace this, and then I'll have here as my products, and so I'll have this alkyl alcohol and this sodium bromide. So in an electrophilic aromatic substitution, we have a two-step mechanism. First, an electron poor reagent reacts with an electron-rich aromatic ring. Let's say I have this. So this reaction will yield a carbocation reaction this way. And then on the second step is the abstraction and subsequent elimination of the proton from the aromatic ring. So the bromide here will have to take up the proton from the aromatic ring here, and then I'll have the products because this is reacting with this proton. The next is the free radical reaction. So the free radical reactions are hemolytic processes which involve species with an odd number of electrons. So a good example is the reaction between alkanes and halogens in the presence of sunlight. So let's say I have CH4, which is methane, reacting with this, that's chlorine, in the presence of sunlight. Which is a UV. So this will yield a chain of reactions. So this chain of reaction actually involves steps from initiation to propagation and then to termination. So we've seen it. So the next type of reaction to consider is the elimination reaction. So elimination is actually best understood as an inverse of addition reaction. Now, let's recall that in addition reaction, a double bond is actually reduced to a single bond. But here in elimination reaction, the reverse is the case. A single bond will actually result to the formation of a double bond. So if I have this, that's ethanol. So I have H2SO4 as a catalyst. Now this reaction will result to a double bond here, where water is generated. So on the product side, I'll have an ethene plus water. So this is an example of elimination reaction. We form a double bond from a single bond, whereas in addition reaction we form a single bond from a double bond. So lastly, we'll talk about the rearrangement reaction. So for the rearrangements, these are simply reactions with the rearrangement of carbon atoms in the basic skeleton of the molecule. So if I have CH3, CH2, CH and CH2. So with this yielding CH3, CH, CH, CH3. Now the only change in this is the rearrangement of the basic skeleton. So such a reaction is termed a rearrangement reaction. So this is one butene, whereas this is two butene. So you see that the product molecule actually has a different basic skeleton from the reactant molecule. So the position of the double bond simply changed from position 1 to position 2. So we call this type of reaction a rearrangement reaction. Rearrangement reactions can also occur by the migration of a group from one atom to the adjacent atom. So guys, that will be the end of this tutorial for this video. If you enjoyed this video, please hit the like button and share the video with your friends for more subscribers. And if you've not yet subscribed, please hit the subscribe button. Thank you.